Welcome everyone, I'm Monica Vink with Ontivity and TIF, and today we're just outside of Bardstown, Kentucky with Ryan Carr and his team from Sabre Industries to go over the aspects of twist and plumb tension activities on guide towers. Today we are going to explore the importance of TPT maintenance, some of the driving standards from ANSI TIA 222, various revisions based on the structure and the owner's program, and we'll be specifically referencing the ANSI TIA 222 Revision I with an effective date of 1/1/2024. In addition, we'll be learning from the competent team members, as well as going through the equipment necessary to get the job done properly.
Thank you, Monica. It's great to be here with you and my team to go over such an important topic. Twist plumb and tension maintenance is a vital part to our existing infrastructure, so that way guide towers function as their owner's intended use. Ready to get started?
Let's do this.
Okay.
So Ryan, tell me about what's behind us.
So Monica, this is a theodolite, otherwise known as a transit, and it's probably one of the most important pieces of equipment we need when we're doing twist plumb and tension maintenance for guide structures. The transit is used to check if the tower is within specification on its twist or plumb. After completing a job hazard analysis and a communication plan on the site, this is the first step in the twist plumb and tension process, as stated in the TIF-PAN, twist plumb and tension for guide structures. It's also a good idea to have more than one transit, unless you like walking a ton, to properly monitor the twist and plumb. We set one transit up directly into the leg of the structure, and that one actually measures if our tower is plumb. The second transit or theodolite is set up perpendicular across the back face. That allows us to measure our twist. Special note, there are certain situations where a third transit is required.
Thanks, Ryan. So the twist and plumb are very important, yes?
Yes, Monica, you could say they are essential. Too much twist, more than 5%, or too far out of plumb, and the tower will not perform as designed. The good news is ANSI TIA 222 standard Annex J, there is an outline for capturing this data.
So tell me why checking twist and plumb is the first part of the process.
Well, that's a great question, Monica. The reason that we check our twist and plumb first before we get into our day's activities is we need to understand what's actually going on with the structure. Too much twist, or if the tower is not plumb, it'll actually change our activities at the anchor heads. It's also a really good point to go ahead and check the tower for any microwave antennas. Since we'll already be scanning the tower from bottom to top and back down again, we can identify if the day's activities and any kind of adjustments might be service impacting, since that's why these structures are here to begin with.
So how do microwave antennas play a part in TPT maintenance?
Well, microwave antennas don't actually directly play a role in twist plumb and tension maintenance, but we have a potential of actually causing disruptions with microwave links if a tower is twisted or if it is too far out of plumb. The network, again, being the reason why these structures are here, it is up to us as the contractors to make sure we do our due diligence and identify who owns that microwave antenna, properly communicate to the owners of the microwave antenna, so that way we can have a technician on site with us during our maintenance process to monitor RSLs. Remember, it's not just about the one microwave link that we're talking about. This could actually impact network flow downstream and potentially put a lot of our end users out of service.
So that's quite an involved process, and we haven't even turned a wrench yet.
That's correct, Monica, but the preparations to completing a proper TPT are critical to the structure owners, the carriers, and everybody else involved in the process. Add to that, it is a very efficient process when working with an end user or structure owner that already has a well-managed maintenance condition assessment program set up. When we have those programs set up, communication becomes very efficient. In order to proceed with TPT maintenance, we have to understand the twist plumb in the structure. It's also a step we have to take before we can begin.
Tell me what else we have to do before starting TPT activities.
So Monica, once we've actually established our twist plumb readings, whether they are compliant with ANSI TIA 222 or not, and we verified whether there's microwave on the structure, the next step that we have to take is we have to get our wind speed, the direction the wind is blowing, and our ambient temperature outside.
What does the temperature have to do with it?
Well, Monica, the temperature is very critical when it comes to TPT maintenance because the temperature is going to affect what we actually set our guide wires to. As temperatures rise, steel will expand, which means we're going to set our tensions lower than what a 60-degree design tension might be. As on the flip side, if it's colder, a day like today when we're down here in Bardstown, Kentucky, we're actually going to be setting our tensions a little bit higher than what they would be on a 60-degree design.
So what's next, Ryan?
So the next thing that we need to do, Monica, is we need to go out and we need to make sure that we find the most recent structural analysis for the specific site that we're on. When we have the most recent structural analysis, that is going to give us the best information for that structure at that time. Many folks think that guide wires are to be set at 10% of breaking strength, and where sometimes that actually might be the case, oftentimes our engineers will actually use design adjusted tensions to meet the structure or code requirements. And based upon ANSI TIA 222 Rev I, they're allowed to go from a band of 7% all the way up to 15%. That information is what we're going to find on our structural analysis. And by following the most recent information available, that's what guarantees us as contractors to be able to actually fit into what the engineer of record says is specific for that one site. Now that we've actually done all that and we can figure out where our tensions need to be set based upon the EOR's information, now it's actually time for us to gather our tensions. And with the introduction of ANSI TIA 222 Rev I, there are 4 recognized methods for gathering tensions. There's direct method, there's time pulse, slope intercept, and shunt meters. And today, we're actually going to be using direct method, as that is the most typical and standard method for TPT maintenance. That's it. Now we can actually start to turn some wrenches and have some fun.
Awesome, let's do it.
This equipment is an investment. The transits, dynameters, and shunt meters typically range from $1,500 to over $6,000. On top of that, all those pieces of equipment have to go in for annual calibration. Having precision measurement equipment that's out of calibration is like having no equipment at all. The other side of that is if transits, dynameters, or shunt meters are dropped or impacted outside their intended use, they have to go back for a recalibration to ensure reading given are accurate. It can get very costly for us contractors pretty quick. The other equipment isn't much cheaper. Chain jacks, wire rope pullers, and smooth jaw wire clamps all come with a heavy price tag. A full set of properly calibrated twist, plumb, and tension equipment can cost a contractor between $15,000 and $25,000 depending on the setup. It goes without saying that the larger the structure, the larger the investment on equipment might be to be able to make sure that you are completing the work properly and safely. Now that we've gathered all of our baseline information, it's actually time to start to get to work. When we're addressing our TPT maintenance, it's critical that we actually take care of any twist or plumb issues prior to adjusting the tensions. When it comes to twist plumb, this can be the most time-consuming part of this maintenance process, depending on how far a tower might be out of plumb or how far a tower might be twisted. But to get started, we're going to load up all of our wires that need to be addressed with our smooth wall wire clamps, our dynameters, and chain jacks. The reason that we use a smooth wall grip is because we don't want to cause undue damage to our guide wires with tooth grips. Tooth grips can actually cause damage to the galvanizing, which can lead to premature corrosion. They can also cause pinching and potentially bird caging in the wires. Once we've done that, going in and actually addressing the twist or plumb issues on a structure might require several cycles of moving up and down the tower to where we can actually get the tower back within tolerance. The reason that this has to be addressed first is depending on how far a tower might be out, we're going to take the tensions outside of their specified ranges to actually adjust this tower. Okay, now that we have our alignment issues fixed on this structure, it's actually time for us to set the tensions, making sure that we follow the most recent SA and the engineer records requirements and specifications for this tower. During this portion of twist, plumb, and tension maintenance, it's absolutely critical that we are continually monitoring our structure. We just fixed the alignment issues. We don't want to put alignment issues back in the tower as we're setting our tensions. One thing is also make sure that we need to note while we're doing direct method is going to be turnbuckle take up as we're actually dropping loads off of our load cells. Now that we've completed our twist plumb and tension maintenance, it's time for us to actually put this site back together. The first step in closing out twist plumb and tension maintenance, well, we obviously have some crew members cleaning up, is to get our turnbuckle safeties reinstalled. Properly installed turnbuckle safeties need to be routed in between the fan plate and the turnbuckle, through the body of the turnbuckle, and through the thimble in our preforms. Please remember it is critical that we are routing the front portion of our safeties through the thimbles and the preforms as opposed to the eyelets and the turnbuckles. Safeties over time can cause damage when they rub up against steel. And replacing a thimble inside of our guide system is a lot less intrusive than actually replacing a turnbuckle. Once we've got our safeties reinstalled and everything looks good, now it's time for us to apply a zinc-rich coating like Zinga or Zinc Coat. When we're out here to do twist plumb and tension maintenance, since we're here, we have the equipment, it's always a good measure for our tower owners and the end users that we treat everything inside of our guide system that we've touched and anything that's accessible from the ground. This includes fan plates, our turnbuckles, where our grips were installed on the wires, and the wire rope clamps that are installed on our safeties. Once we've applied all of our zinc-rich coating, then we can go ahead and proceed with our closeout photos. Your customer will let you know what closeout photos that they actually want for the twist plumb and tension maintenance. On top of those closeout photos, we also need to make sure that we're filling out an ANSI TIA 222 Rev I Annex J style closeout form, so that way we're meeting the standards requirements and our customer requirements.
Ryan, I just want to thank you and your team for coming out today and walking us through the complexities of TPT maintenance. I know there are several individuals in the industry that will find this very valuable.
Monica, it was our pleasure, and we are always here to support the telecommunications industry. Stay safe.
We hope you enjoyed this video as much as we enjoyed putting it together. There is additional information on this and other subjects on the TIF site. It is important to know that there are many additional steps, and this video was just an overview. Finally, we want to thank all the manufacturers, end users, structure owners, engineers, and the men and women who make telecommunications work for all of us. Thank you.